All right, so there's a few tables, and these are the tables that I'm actually taking Major Adams' slides directly and showing them to you. So if you see this table, this is one that you want to tab because it's the thing we learned last, and when you start to compile things, the thing you learn last is the hardest to remember. So you're going to have to be a little bit more putting the directions down on this section. So causation. There's a ton of studies in nutrition that are all observational. All the dietary supplement stuff that you guys are talking about, they're all observational. I'm recording this, so I can't really talk about it, but to really do a protein supplement, like you asked me about protein supplements, to really do that right and know whether a protein supplement helps someone, you need to have an outcome variable, a research question design, and to really know whether you got it right, you need to have two groups. You need to have a group that's a intervention group, they're going to get the protein supplement. You need to have a control group, they didn't get the protein supplement, and then they're both doing the same things. And also, when you put them into these two groups, you have to randomize them. And so I work with people who do randomized controlled studies. When you take a group of people that have consented to be in your study, you have to assign them to the control versus the intervention piece. This is actually something very difficult because think about something like a drug treatment for cancer. Who wants to be in the placebo control group? Nobody. And you also want it to be blinded so that the person doesn't know which one they're getting. So when they sign the consent to get into these studies, they have to sign something knowing that this is an experiment, you may be assigned to the control group, it may happen. And it's not a therapy actually, it's an experiment. So that's how we do it right. And that's the gold standard for how we know whether something caused something else to happen. To date, I went through the literature for you and this looked. I don't think there's a study where they gave two groups like that who are doing the same thing, lifting, and then actually looked at the outcome between the two on a protein supplement. They're what we call observational studies. They looked at a group of people that are taking the protein supplement and then looked at the outcome. What could happen with that, with the observational study?
There can be other variables affecting it.
Right. And there could be a group that just like to lift more. Maybe they ate more in general. It's the big question for me is it calories or is it the protein? I think I saw a nice study where it actually looks like it's the calories. Anyways, observational study versus experiment, you should know what the difference between those two are. And we have a lot of actually articles that my team has written on observational studies and why you cannot sometimes make a conclusion from that. Eating blueberries makes you live longer. How would you know that? Those are like media, like you see those lines in the headlines. How would you know that? How would you design a study for that?
Everyone's different.
Well, people always use statistics to prove things. What they use is like they believe that blueberries is something like beneficial to your body, and that action from the body then makes you live longer. That's
called the alternative hypothesis, right? You have to set it up in a rigorous way, right? When you have some evidence, let's say we start in mice first, and we test things out. Then we come up with a hypothesis. This thing does a good thing in mice. Now I want to know if it translates to humans. Then I have to do the RCT. That's the gold standard.
Well, I wouldn't think that you'd ever be able to do that. Technically, there's so many factors influencing life. So I feel like it would be reasonable to say, all right, let's say blueberries produce T thing in your body or X thing in your body, and X thing makes you live longer because it does Y function. Then technically you could be like, all right, I experimented by taking people with blueberries and they produce more X than the average person. Therefore, I can conclude that even though I'm not going to follow these people for 80 to 100 years or whatever, or 80 to 60 years, I can conclude that they live longer.
All right, hold that thought. Okay, I'm going to tell you about a study that they actually did run the RCT after years, and it was mortality and weight loss. Right, so if you're a little bit chunky, you're my age, and you go to the doctor's office, they'll recommend, it's a treatment now. I recommend you lose weight. And the reason is they assume that it's hooked to mortality. Right, we'll come back to that because I don't want to divert from this quick lecture. But what's funny is sometimes you know those internal things are happening and they don't translate to the RCT. But this is important. The 4.1 is a short lesson, it's a short amount of pages. And I would I'm going to give you an order what I think I would do and I was a good studier. I did it for a lifetime. So I'm going to give you the order of what I would do if I was studying for the test in your shoes, in your boots. This is the terminology that Major Adams highlighted. Go ahead.
So for a lot of tests here, we have old WPRs that we can study, but since this is a new class, there's no old WPRs.
So I'll tell you one thing that's different in this class. You really have to actually know it. You can't just memorize and stick yourself through it.
Yeah, but a sort of format, idea of how it's going to be formatted per se.
I have a quick question going along with that.
Okay.
Would there be any code on there?
Yeah, there is.
Oh,
So,
thank you.
yeah.
Okay.
Yeah, I just looked and they sent a data set, so there is code on there. I'll tell you what I would do for that.
Can we pull old code?
No, you can't, but you can write in your book.
And
And I'm gonna allow you to put a page on the front cover and back cover so that where they are writing, you're not writing in that book, you're actually putting it on the front cover, back cover.
And when did you say you were going to send us the answers?
I don't need to send you the answers, you have them all up here. So a couple of these terminologies, I'm just going to give you the quick and dirty, but look in the book. Explanatory variable, it's a variable that explains an outcome, or that you think explains an outcome. I'm going to come with this example in a bit. I served on a board of ed in Randolph Township in New Jersey. We always talked about school rankings there, and they would say, well, Chatham's better than us because they're ranked higher. So what could be an explanation? So the explanation for that is that the school is solely responsible for its ranking. Whatever they're doing in the school, the explanatory variable, the education they're getting in that school, is responsible for the response, which is the school ranking. So one explains the other. The responses is what's being explained, and the explanatory variable is what's doing the explanation. And you can have more than one. Confounding variable, so this is what I brought, and this is where Ryan and I talk about how to explain things. So I came like Poindexter and said, look, there's a confounding variable here. It's called income. There's data showing that parents who have higher levels of income will educate their children differently at home. And, watch over their homework, for example, or hire a tutor, or I bought my son SAT books and ACT books, so I could buy it because I had more income. So income is what we call a confounding variable. And Chatham's income was higher than Randolph's income. And so you cannot say just what we did in the school is what's going to be this response variable. That's what we call a confounding variable. Observational study versus experiment, I just gave you that. Observation is, I looked into a population, people with higher BMI said they drank more soda. From that I can't conclude, though, that that soda makes people get big. I can't make that conclusion. It's an observational study. My friend always says observational studies are evidence for a conjecture. They're not support for the conclusion. Randomized experiment. I just gave you an example of that quick and dirty. Double blind is where people don't know which thing they've been assigned to, and the researcher also doesn't know which thing they're assigned to. You can imagine that if I was an investigator and I was really into my drug, that I want it to work. So if I knew that, hey, you're in the actual experimental data, I might actually mess up the data myself. And so double blind is when we both don't know.
How do you account for the placebo effect? Because sometimes.
Well, if you have a control group that's getting the placebo, what you want to see is an effect that's higher than that control group.
Because I remember, I forget where I learned it from, but sometimes people's bodies will react when they think they're taking something.
That's right. That's called the placebo effect, right? So what you need is this control group is getting a pill, but they don't know whether it's the real pill or not. And this group is the intervention group. They're both getting the same colored pill, but they and both don't know which group they're assigned to. And then you look at the results of this group, and you look at the results of this group, and just like you're saying, am I away from the null? Am I away from these guys?
Okay.
Right? If I'm away from these guys, then I've accounted for the placebo effect.
Okay.
Major Adams made this chart. I'm going to send these out to you, too, to look over. But confounding variables can affect more than just one piece. For example, I asked my friends, they're actually away right now, so we write a lot of papers in rigor and reproducibility, but they're away and they couldn't give me another example. the example we always look at is breastfeeding, and I said, I don't think my kids really care about that, hopefully not, because it's probably not something you should be worrying about right now. But breastfeeding is one of these things that it's in medical practice. When I had babies, there were these women that used to come into my room and tell me how great it was to breastfeed, and then about formula, and so, they were giving me treatment recommendations about breastfeeding. Breastfeeding is one of those things that has a confounder. When they look at breastfeeding studies, women who breastfeed can breastfeed, and if they can breastfeed, it means they're not standing on their feet in Walmart all day. And so a confounding variable against economic status. And so a lot of these papers about breastfeeding have this confounder in it that they haven't adjusted for. And there's unknown confounders too. So there's things in there that you haven't accounted for. So the confounder may just affect the explanatory variable. Breastfeeding makes healthier babies. Breastfeeding makes, you might have this confounder. You actually could stay home. You had enough money to stay home and breastfeed. And so therefore that actually affected this variable, what you're trying to explain. And I gave you one, that the Board of Ed one I gave you one is this one. Income affects what you do at home. How you do things at home is very different. JJ, you and I have talked about this actually. What I did at home and what my parents did at home, my dad was a doctor. So, what he did at home was watched over my homework all the time, made sure I brushed my teeth he brushed my teeth for me every night for a long time. He was enraged about all the health things I went through. So my income at home actually affected what I did for education at home. But also, people who have more income are more involved in the school. So if they're more involved in the school, then they're going to affect the education in that school. So that confounding variable of income affects what you do at home, the explanatory variable, or and it also affects both the response and the explanatory.
I'd say that's to a certain extent too, though. So I have a lot of buddies who have very wealthy parents who are just traveling all the time and are just not doing anything in their lives, a decent amount. So I guess it is a variable, but it's not very cool.
But you just don't know how much to account for that. And my parents and I talked about this because I grew up in a hick town. I think I was one of the only people to go to college. And when I try to explain what I'm doing right now, one of my friends looked at me and said, "You just love to study." It's a weird thing. And my dad used to always pick on me because I would go out and do stuff with my friends that I probably shouldn't have been doing. I grew up as a hick. And I told my dad, if you didn't want me to be friends with those people, my friends, then you shouldn't have moved here. But I ended up like you, didn't I, at the end of the day? So don't tell me income is not a confounder. Whatever he was doing at home and my mom was doing at home, they were united in the fact that I had to study.
That's not income, that's more background, that's like your parents.
But that has socioeconomic status. My parents were immigrants, but they were not poor immigrants. They came here from a professional family, both of them. So it made a difference.
But there's a lot of poor immigrants that are raised, it's like a lot of it's like, I don't know how to say it, it's not like a bias, but a lot of, and the Chinese culture and the Indian culture, it's very, academics is very strict, I guess. So.
At least the ones that come here. If you actually go to India, there's a lot of people who don't have that culture.
That's what I'm saying. So then the income isn't as much as a variable, it's more just your background.
It is. So you might have more than one confounder, but income is a huge help to this, right? It is. Because even if you're traveling, you can still hire a tutor. Yeah, and that's what they do in my town. They hire tutors. It's being recorded.
I think what he's not understanding is the correlation between background and income. So just for my experience, I used to I was in the foster care system and lived with a poor family, so I didn't get access to tutors and stuff. But when I got adopted, I went to a wealthier family and I could go to tutors and all that sort of stuff. So the amount of income you have does sort of.
I understand that, but it's to a certain extent because sometimes
right. So what he's saying is there's two confounders, right? My parents were also super educated, and then right now my husband has a master's degree. When we stand with his family, they're Tamil Brahmins.
Yeah.
There's PhDs all over the place standing in the room. And I'm just a mere PhD in math. They're PhDs in engineering, and they have MDs. So we're standing there, and guess what happened to my son growing up? When he was 3, I was teaching him about prime numbers. Mm-hmm. That's not normal in my hometown. People don't teach their kids about prime numbers when they're 3 years old. So background does matter. right? And I can tell you, being a mathematician in an academic setting doesn't make me super wealthy. So there, it's not like I'm the richest person in town, but the background mattered, that I was in education itself. High school teachers will bring that background. So that's another confounder. So you don't have to have one confounding variable. There's also unknown confounders, what we don't know about. The only way you can account for unknown confounders is this setting, right? If you take a population and randomize them to control an intervention, that's the only way you can handle unknown confounders. This picture is really super important that it like makes my head buzz. You might I might look at this over the weekend and see if I can break it down in a simpler way, but they're saying exactly what I just told you now. Like, when can I draw an inference and when can't I draw an inference? When am I gonna have a problem drawing that inference? And so they talk a lot about this. This section 4.1 for you as a human being is really important. Because when you leave here, people are going to give you information. When you get that information, something in you should always stop and ask, how do I know that? Example, in my department where I used to work, they said, don't give students calculators. Because calculators make students not learn as well. And I thought, my work is all in fitness and nutrition. I wonder if this is true. How would someone know that? They actually have run studies. And guess what? Giving students calculators doesn't make them less number sense. It makes them better. And so I came back with the RCTs that they actually ran. West Point knows this, right? They're giving you computers and R, and they're doing the right thing. But when you go to educators, they went with their gut feelings and beliefs. We need to get that t-shirt, right? In God we trust, and all others must bring data. And I was surprised, because we're the Department of Data, and I couldn't convince anybody. Their beliefs held strong. All right, he mentioned this Exploration 4.1. If you get time at the end of your studying, I would actually go to that and look at it, just to read through it. You don't have to answer the questions. I know how time goes, so I'm going to give you like what I would do first, what I would do second, and then if you run out of time, you put the lower hanging fruit at the end, like the things that are not going to give you the most bang for the buck at the end. Make sense? Okay.